Hi guys, today we're going to be looking at A-Level Further Maths, October-November 2023, paper 1-1. So, first question, we have the summation question. So, we need to consider this and use the method of difference to prove this. Okay, although we have this in the formula booklet already, we cannot just say that, oh, because it's in the formula booklet and we don't have to prove it. So yeah, let's start. So first we'll be looking at r plus 1 squared minus r squared. So this will be 2r plus 1. So now we'll just leave this aside and we'll do the method of differences for now. So the summation of r plus 1 squared minus r squared So method of differences, we just need to consider for r equals to 1, r equals to 2, r equals to 3, so on. And for the final few, we can do r equals to r equals to n minus 2, r equals to n minus 1, and r equals to n. So starting from r equals to 1, we will have 2 squared minus 1 squared. This is 3 squared minus 2 squared. Basically, we just sub these numbers into this whole thing. So since this is a summation, we're going to sum all of this up. So we can see that 2 squared and minus 2 squared can be cancelled off. 3 squared and minus 3 squared, so on and so forth. So, oh sorry, this is 4 squared. So 4 squared and the other 4 squared here will be cancelled off. So this will also be cancelled off. This and this, this and this. So now what we have left is n plus 1 squared minus 1 squared. So we only have this and this left. So now we know that r plus 1 squared minus r squared is basically 2r plus 1. So we can also write it as the summation of 2r plus 1 is equals to n plus 1 squared minus 1. So the 2 can be taken out to write it as 2 times the summation of r plus summation of 1 equals to n squared plus 2n plus 1 minus 1. So this is plus, so this will be n, because basically this is when you plus 1 times 1 plus 1 plus 1 plus 1 for n times. So that will be n, so equals to n squared plus 2n. So since you're trying to find for summation of r, we will make this the subject. So it's equals to n squared plus n, and the summation of this will be half times n times n plus 1, and this will be equals to this one. So for part B, we have this equation. We are given with this equation and we need to find a in terms of n. So basically we can separate these two terms. We can write it as the summation of r plus the summation of a equals to n. So the summation of r is basically half n times n plus 1, which we already proven it just now, plus we can write this as a times the summation of 1. So let's just expand this first, plus an equals to n. Hence we can divide the whole equation by n. So half n plus half plus a equals to n, and a equals to half minus half n. Oh, sorry, it should be 1. Yes. So that would be the answer. The next question will be about mathematical induction. So for mathematical induction, we need 3 steps. First step, prove it when n equals to 1. Second step, when n equals to k. Third step, n equals to k plus 1. And what do I mean by that? I'll show you now. So for n equals to 1, we need to prove that the left hand side is equal to the right hand side. So for left hand side, which is this part, it's basically 1. And for the right hand side, which is this part, we have n minus 2x plus x squared over 1 minus x squared. And this will be, can factorize this, equals to 1. Hence, left hand side equals to right hand side for n equals to 1. So the statement is true for n equals to 1. Okay, this will be the first step. Second step, for n equals to k, we assume that the statement is correct. We assume that this statement is true. Third step, for n equals to k plus 1, we need to verify that this is true as well. So we need to prove this. So basically we sub, for this part we sub all the n's to be k plus 1. So we'll start proving it now. Left hand side. So this part is basically this part. So from the second part, we assume that this is equal to this, right? So we can sub the whole thing into the equation. We can write it as this. And remember to add the last term. Okay. So let's make it into one fraction. So now let's group the terms according to the power of x. So for x to the power of k, we have minus k minus 1 plus k plus 1. And for x to the k plus 1, we have k minus 2k minus 2. And for x to the k plus 2, we have k plus 1. So this will be 1 minus k plus 2 x to the k plus 1 plus k plus 1 x to the k plus 2 over 1 minus x squared. And this is basically what we want here. So this is the left hand side is equals to the right hand side. Therefore, left hand side equals to right hand side statement is true for n equals to k plus 1. To conclusion, by mathematical induction, statement, this statement, this one, is true for all positive integers n. For the last part, right, for this part, for all positive integers n, you just have to refer at the question. So I just copy it back. For this question, we need to find the values of b, c, and d. So what we need to know is b is this, c is this, and d is this. Since the coefficient of x to the power of 4 is just 1, we can say that this is just this. If the coefficient is a, then this will be different. It will be b over a, c over a, and d over a. Since a is just 1, so we can just ignore them for now. Okay. So b is just okay. So this is the sum of root square and the sum of root inverse. So b is basically just -3. Because this is just this. And we have this equation. The sum of the root square is equals to the square of the sum of roots minus 2 sum of alpha and beta. So this is 5 equals to 3 squared minus 2c. 2c is equals to 4, c is 2. Okay, and for the last part, to find d, it's slightly harder. So we have, okay, let's copy this equation here first. 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta is 6. So let's make it into one fraction. Okay, so this is basically the sum of this. So this thing is basically minus d over the product of roots is this one minus 2 equals to 6. So d is basically 12. For part B, before doing, I will need to prove something to you guys. Okay, before that, let me just copy the equation here so we don't have to scroll back up every time. Okay, so the roots are alpha, beta, gamma, and delta. So, okay, when x is alpha, so when alpha is the root, we get alpha to the power 4 plus b alpha to the 3 plus c alpha squared plus d alpha minus 2 equals 0. When it's beta, we get b to the 4 plus when it's gamma to the 4. When it's delta, okay. If we add all of the equations up, we get this. But this is also basically minus 2 times alpha to the power of 0 plus beta to the power of 0 plus gamma to the power to the power of 0 plus delta to the power of 0, right? For this one. Because this is up to 4. So this equation and this equation look similar, right? So we can also conclude that, okay, let's call this S4, let's call this S3, this is S2, this is S1, and this is S0. So we can say that we can basically just put this in the equation. S4 plus B S3 plus C S2 plus D S1 minus 2 S0 equals to 0. Because this is basically this in some sense. So during the exam, you don't have to prove this whole thing. I'm just showing you why you can use this equation to write it in this form. Alright. Okay, so now we can start doing. We are given that this is S3 basically. S3 is minus 27. So S4 plus what is B? B is minus 3. Minus 3, S3 is minus 27. Plus C is 2. And S2 5, which is shown here. This is S2. D is 12. S1 is 3. This is S1. Minus 2. What is S0? So S0 is basically this thing. And these are all 1, 1, 1, 1. So it adds up to 4. So S4 will be equals to negative 119. For this question, we have two lines. This is L1 and this is L2. So we need to find the shortest distance between these two lines. So the formula for shortest distance is this one. So these two are basically the points. Okay, point on L1 and the point on L2. Or you can search L2, L1, same thing. This is the unit vector of the normal. Normal will be the cross product of the two directional vectors of L1 and L2. So this is the directional vector of L1, this is the directional vector of L2. So we call it D1 and D2. So now we'll try to find for A minus B. A minus B is basically this minus this. These are the points on the line. So N will be minus 4, 3, 5 cross product with 2 minus 3, 1. And this we can factorize the 2 out, so we get 9, 7, 3. So for now we just plug it into the equation here. So A minus B is minus 4, minus 1, minus 8 dot product with the directional vector, sorry, the unit vector of the normal. So this is A minus B. This is the unit vector of n. Because it's distance, so we will find the modulus of the whole thing, just in case the answer that we found is negative. So 67 over 139 will be the answer for the shortest distance between L1 and L2. Plane contains L1 and a point with position vector -1, -3, and -4. So this plane, oops, this plane has L1, this is L1, and a point with the vector, the position vector, -1, -3, -4. So to find the equation of the plane in this form, we will need the normal of the plane. But how do we find the normal? We have one directional vector from L1, which is the directional vector of L1 is -4, 3, and 5. Now we need another directional vector. Let's call it D3, because D2 is already used here. To avoid the confusion, we will use D3 as the other directional vector. So how do we find for this directional vector? Look at this. We have 2 points actually. Remember that in L1, we have this point, -2, -3, -5. -2, -3, -5. So we can actually find the second directional vector by just doing this. Oh, sorry, this is 0. We can factorize the -1 out, so we get 1, 0, 1. It will be easier for the further cross product. So D3, oh sorry, D3 is 1, 0, 1. And now we can find for the normal vector. So to find the equation, this will be the formula. R dot n equals to A dot n. So what is R? We can just put it as x, y, and z. Dot product with the normal vector 1, 3, -1 equals to A. A can be any point on the plane. So let's use this. It looks nicer. So now we just find the dot product. So x plus 3y minus z equals to -6 will be the answer, will be the equation for the plane. For question 5a, it says that A is singular. That means there's no inverse for A. And that means the determinant of A equals 0. Because the inverse is 1 over the determinant times something something, right? So when this is equals to 0, this whole thing doesn't exist. So first we will find for k, since we already know that the determinant is 0. So we can just take this equals to 0, and k will be equal to 2. So now we can find for CAB. So CAB, we literally just times all of them together. Take note that for matrix, you either do this first or you do this first. So you cannot be like, oh, I times this and this together first and then only I times this. No, it has to be in sequence. So I will do these two first. So literally you just take this row times this column. So this times this plus this times this plus this times this. You get the first number. Then for the second number, for this number, you get this times this plus this times this plus this times this to get this number, which is -3. And similarly for this, you get this times this times this, and this times this. And this is the same thing. This row times this column for the first number, this row times this column for the second number, this row times this column for the third number, and this row times this column for the last number. So we will get 3, -7, -9, and 3. And yes, it's the same answer. For part B, we need to find the invariant lines through the origin. So invariant lines are basically that the object and the image are in the same line. So let's say O is my object. The image will be along this line, either here, 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 just anywhere along the lines. So if the coordinates is x and y for O, then the coordinates for I, let's say I put the capital X and Y. And since the invariant lines is through the origin means this will be the equation of the line since there's no y-intercept. So I can change this to x and mx, and this is x and mx since they have the same gradient. So let's start. This is the matrix, the transformation matrix, and we times the coordinate of the object to get the image. So for now, I just need to multiply it in this way to get x. So 3x minus 7 in x equals to the capital X, and this times this to get this. So the second equation will be -9x plus 3mx to get this. This will be the first equation, and this will be the second. So this is basically just simultaneous equation. We can take the second equation to be divided by the first equation. So we get negative 9x plus 3mx over 3x minus 7mx equals to mx over x. So we can cut off the x's. And now we get negative 9 plus 3m equals to 3m minus 7 whole square. So now you just need to solve the equation. Solve the quadratic equation. So 7m squared equals to 9 m equals to m squared equals to 9 over 7 and m equals to plus minus 3 over 7. So the first equation of the line will be y equals to 3 over 7x, and the second equation will be y equals to negative 3 over 7x. For part B, we need to find the invariant lines through the origin. So invariant lines are basically that the object and the image are in the same line. So let's say O is my object. The image will be along this line, either here, here, just anywhere along the lines. So if the coordinates is x and y for O, then the coordinates for I, let's say I put the capital X and Y. And since the invariant lines is through the origin means this will be the equation of the line since there's no y-intercept. So I can change this to x and mx, and this is x and mx since they have the same gradient. So let's start. This is the matrix, the transformation matrix, and we times the coordinate of the object to get the image. So for now, you just need to multiply it in this way to get x. So 3x minus 7 and x equals to the capital X, and this times this to get this. So the second equation will be negative 9x plus 3mx to get this. This will be the first equation, and this will be the second. So this is basically just simultaneous equation. We can take the second equation to be divided by the first equation. So we get negative 9x plus 3mx over 3x minus 7mx equals to mx over x. So we can cut off the x's. And now we get negative 9 plus 3m equals to 3m minus 7 whole square. So now you just need to solve the equation. Solve the quadratic equation. So 7m squared equals to 9 m equals to m squared equals to 9 over 7 and m equals to plus minus 3 over sub 7. So the first equation of the line will be y equals to 3 over sub 7x, and the second equation will be y equals to negative 3 over sub 7x. Part C. We need to find the matrices D, E, and F that represent the geometrical transformations. So D is an enlargement. They didn't tell us the scale factor, so let's call it K first. And E is a stretch parallel to the x-axis. And they also didn't give us the scale factor, so let's call it H. And F is a reflection in the line y equals to x. So that means the gradient of the line is equals to 1. Given that CAB equals to D minus 9EF, we need to find DE and F. Okay, so for matrix D, we can write it like this. Since it's an enlargement, this is the form for enlargement. E is a stretch parallel to the x-axis, and we can write it like this. F, we can write it like this. So what is theta? What is this theta? We can find it by using m equals to tangent theta, and m, as I said just now, it's equals to 1. So tangent theta equals to 1, and theta in this case is 45 degrees. So cos 90 is equals to 0, and sin 90 is equals to 1. So f can also be written as 0, 1, 1, 0. So now we write it in this form. So d minus 9e f is equals to this one, CAB. It's 3, negative 7, negative 9, and 3. So now we just need to do it step by step. We're gonna times these two together first. So we get 0, h, 1, 0. And we can see that to find k, we can just use this, and this. So k minus 0 equals to 3, k is 3. And to find h, we need to use this, and this. 0 minus 9h equals to negative 7, and h is 7 over 9. And that's it. So d in this case is 3003, and e in this case is 7 over 9, 0, 0, 1. And f is already here. We need to change this Cartesian equation into the polar equation. So let's expand the bracket first. So we can group the x squared plus y squared together and minus x equals to 0. So for this, we can change it to r squared, and x is r cos theta. And then we can factorize the r out, so you get r equals to cos theta. And in this case, r is not equals to 0. It can't be equal to 0. If not, the whole equation will not exist. So we have two curves here, C1 and C2. They intersect at the pole and at another point P. And now we have to find P. So you just equate these two equations together. And you can change sine 2 theta to 2 sine theta cos theta. And factorize the cos theta out. So you get cos theta bracket 2 sine theta minus 1 equals to 0. And cos theta equals to 0 and sine theta equals to 1 over 2. For cos theta equals to 0, theta, oh, sorry, cos theta cannot be 0, if not r would be 0. And first we need to find p instead of the pole, so you can just ignore this for now. So sine theta equals to 1 over 2, theta is pi over 6. And in this case, r will be equals to sec 3 over 2. So p is sec 3 over 2 pi over 6. This is the coordinates for point P. So for now, we need to sketch the graph C1 and C2. So let's write down first. C1 is r equals to cos theta, and C2 is r equals to sine 2 theta. So to sketch the graph, we can roughly write out what um, the figure that we have in the graph. So we can do it for theta equals to 0, theta equals to pi over 6, theta equals to pi over 3, and lastly pi over 2. These are the more usual numbers that we can see. So when theta is 0, r equals to 1, this is sec 3 over 2, this is 1 over 2, and this is 0. And for C2, we do the same thing. We roughly see what numbers we can get for each theta. This is 0, this is sec 3 over 2, this is sec 3 over 2, and this is 0. We can see that this is like a symmetrical kind of shape, but we need another number to know um how the shape actually looks like. So we get theta equals to pi over 4 is equals to 1. So we can roughly know how it's shaped like. So let's sketch the graph for now. First we need to do it for this range only. So yes, this will be 0. This will be pi over 2. And we can have pi over 4, pi over 6 around here, and pi over 3 is around here. This is pi over 6, this is pi over 4, this is pi over 3. So let's start with C1. When theta is 0, r is 1. That means it should be around here. This is the first point. Second point, r is sec 3 over 2. Sec 3 over 2 is a bit lesser than 1, so let's just put it here. Sec 3 over 2 and half. When theta is pi over 3, r is half. So let's put it here. And when theta is pi over 2, r is 0 here. So the shape is around, it's like a semicircle. It should be around this shape for C1. For C2, I use another color. Let's use black. For C2, this will be the first point. When theta is 0, r is 0. When theta is pi over 6, r is sec 3 over 2. So it's also around here. When when theta equals to pi over 4, r is 1. So it's around here. And for pi over 3, sec 3 over 2. So around, oops, sorry, around here. Sec 3 over 2. And for pi over 2, r is 0. So it's shaped like a flower petal kind of thing. That's right answer. It's roughly this shape. So this is C2. And we need to identify point P. Point P is where they intersect. So this should be point P. As you can see, when r is pi over 6, when theta is pi over 6, r is sec 3 over 2 for both graphs. So this would be P. So part D, we need to find the area of R. And region R is enclosed by C1 and C2, and this includes the line OP. So the area that is enclosed by C1, C2 and includes OP is basically this area. So it's enclosed by this, and OP is in that region. So how to find the area is that we can divide it into two sections. One is this part, and another one is this part. So after dividing it into two sections, it'll be easier to see. So for C1, we need to integrate it from, for C1, we need to integrate it from pi over 6 to pi over 2. And for C2, we integrate it from 0 to pi over 6. As you can see that this area, this area is C2 from 0 to pi over 6. And after this, we have C1 from pi over 6 to pi over 2. So we can start doing the integration. Area is basically 1/2 of the integration of 0 to pi over 6 for C2, which is sine square 2 theta, plus 1/2 of the integration from pi over 6 to pi over 2 for cos square theta, which is C1. So we can't integrate sine square, so we need to change it into cos. And from the formula booklet, we have sine square A equals to 1 minus cos 2A over 2. So we change it to 1 minus cos 4 theta over 2. Do note that this is 4 theta and not 2 theta because this is already 2 theta. So for cos square, we also need to change it. And from the formula booklet, we know that cos square A equals to cos 2A plus 1 over 2. So this would be cos 2 theta plus 1 over 2. Now we can just integrate it. This is 1 over 2 theta minus 1 over 8 sine 4 theta plus, this should be 1 over 4 sine 2 theta plus half theta. So we just sub in the numbers and we get pi over 12 minus sec 3 over 16 plus pi over 4 minus sec 3 over 8 minus pi over 12. And this would be pi over 8 minus 3 sec 3 over 32. For this question, we need to find the asymptotes of C, and this is an improper fraction. Improper fraction means that the numerator, the degree of x in the numerator is either the same or larger than the degree of x in the denominator. So to find the asymptotes of improper fractions, we need to divide the, we need to change it to another form for the fraction. So x squared plus 0x plus 2. Why do I write the 0x even though it's not in here? It's easier for us to divide it later. I'll show you guys. So divided by x squared minus x minus 2. So put 1, so we get x squared minus x minus 2. And the remainder will be x plus 4. So fx can be written as 1 plus x plus 4 over x squared minus x minus 2. And we can see that there's a 1 here. So whatever that we get here would be one of the asymptotes. So y equals to 1 is a horizontal asymptote. And for vertical asymptote, we take the denominator equals to 0. So x squared minus x minus 2 equals to 0. Factorize it. So x equals to 2 and x equals to negative 1 are also the asymptotes. So these three are the asymptotes of fx. For part B, we need to find the stationary points on C. Let me just copy the equation so that we don't have to scroll up to refer. Okay, so we need to differentiate it to get the coordinates of stationary points. So this is just x squared minus x minus 2. And we differentiate the numerator, which is 2x, minus the numerator and the differentiation of the denominator, which is 2x minus 1, over the denominator square. So this would be 2x cubed minus 2x squared minus 4x minus 2x cubed plus x squared minus 4x plus 2 over the denominator. In this case, we don't really have to expand the brackets because we will end up equating the whole thing to 0. So this would be negative x squared minus 8x plus 2 over the denominator. And now we equate this whole thing to 0. Since the denominator should never be 0, the numerator should be 0. And this cannot be factorized, so we need to use the equation, the formula to find x. So b squared minus 4ac over 2a. So this would be 8 plus minus 6 sec 2 over negative 2. And it would be minus 4 plus minus 3 sec 2. And this is minus 4 plus 3 sec 2 is 0.2. And minus 4 minus 3 sec 2 is negative 8.2. Because we need to change it to 1 decimal place. And now we sub the number back into the equation. We need to use the exact form here, not the 1 in 1 decimal place. So for negative 4 plus 3 sub 2, we get negative 2 sub 2 over 3, which is negative 0.9. And for minus 4 minus 3 sub 2, we get 2 sub 2 over 3, which is 0.9. So the coordinates of the stationary points are 0.2, negative 0.9, and negative 8.2, 0.9. That's it. Okay, for part C, we need to do graph sketching. And the first step for graph sketching is to find the asymptotes, which we already found in part A. So for now, we just need to draw it out. Just now, we know that we have three asymptotes. So y equals to 1, which is here, x equals to 2, which is around here, and x equals to negative 1, which is around here. Second step, we need to find the stationary points, which we also found it in part B. So we have two stationary points. One is at 0.2 and negative 0.9 around here. Another one is at negative 8.2, which is around, let's say, here, and 0.9 for y. So it's around this area. That's that. Find the intersection points with the axis. So to find the y-intercept, stop x equals to 0, and we get negative 1. And for y-intercept, sorry, for x-intercept, stop the whole thing, the whole equation to 0, which we get x squared plus 2 equals 0, and x squared is a negative number, so we have no x-intercept. So let's mark the y-intercept first. It's around here, negative 1. So for now, we need to find the limits of the graph, which means we need to know when x is going to the infinity, do we get the graph here or here? So I have one trick. If you're confused with how to find the limits, you can try subbing x with a large number instead of just using infinity, because infinity is kind of vague. It's a vague concept. So we can use, instead of using infinity, let's use 10,000. So we get 1.0001. That means when x is going towards the infinity, y is very near to 1, which is around this area. this area. Second, let's sub x as 2.001 so we can know how the graph looks like when it's near this asymptote. So we get 2000, which is a large number. So the shape should be like this. When x is near 2, it's a large number, so it's towards infinity for y. And let's find for x before the asymptote. Because this is after the asymptote, now we find before the asymptote. So let's put x as 1.999 and we find that it's equals to negative 1999.3, which is a very small number. So it's towards the negative infinity. It's around this area. And when x is around here, around this area, let's sub it as negative 0.999. We get negative 999.7. It's also a very small number, so it's also towards the infinity when x is going towards negative 1. So we can roughly draw the graph in this area, which is should be around this shape. It passes by negative 1, and this should be the stationary point. So we are left with this area now. So when x is around here, let's sub it as negative 1.001. It's 1000.3 something something. So it's a large number, it's towards the infinity. It's around this part. And when x is a very small number, when it's towards the negative infinity, we can sub it as negative 1000 and we get 0.9990, which is very close to 1 but less than 1. So it's around here. And we know that there's a stationary point here. So the graph should look like this. This should be the lowest point and it's slowly increasing, but it doesn't touch the asymptote. Yes. This should be how the graph looks. And we need to state the coordinates of any intersection of the axis. So this would be the only intersection of the axis. So let's just state that y equals to negative 1. For part D, we will need to find the curve with the equation y equals to 1 over fx. And this is called a reciprocal graph. And basically we need to use the original graph that we sketched and transform it to 1 over fx. So from fx to 1 over fx. And there are a few rules to it. First one, for the asymptotes. The vertical asymptote of fx would be the x-intercept of 1 over fx, and the horizontal asymptote of the original graph would be the same. That means it would still be the horizontal asymptote of 1 over fx. Second turning point, or stationary point. For x-axis, sorry, not x-axis, for the x-coordinate of the turning point, it stays the same. But for the y-coordinate of the turning point, you need to flip the fraction. So basically, let's say the turning point is 2, let's say. It's at 1, 2, let's say. Then it would be transformed to 1 over 2. Okay? And the third one is the limits. So for the original graph, if you have y going towards positive infinity, it would be the 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 graph would be going to the positive side of 0 for the new graph. I'll list out the things first, and I'll explain later using the graph. And for the fourth one, the graph of fx and 1 over fx meet at y equals to 1 and y equals to negative 1. So for now, I've moved this aside first. Make it smaller and move it aside so that we have space for the graph. And let's copy this graph so that we can refer easily. Okay. Firstly, asymptotes. As I said, the vertical asymptote will now be the x-intercept of 1 over fx. So the x-intercept would be x equals to negative 1 and x equals to 2, since they were originally the vertical asymptotes. And for the horizontal asymptote, it stays the same. So we have y equals to 1 as the asymptote as well. Second, turning points. So we need to flip the fraction for the turning points for the y coordinates. So it's still at negative 8.2 for x, but we need to flip the fraction, which means this would be negative 3 over 2 sub 2. So this would be 3 over 2 sub 2. And it's around 1.1. This is 1.1. This is negative 1.1. So this is 1.1. we have the new stationary point here, and for 0.2 we also have negative 1.1. Negative 1.1. So this would be the other stationary point. And third part is the limits. So now I'll explain this part. When y is approaching positive infinity in the original graph, let's say here, it's approaching positive infinity. In the 1 over fx graph, it will be approaching 0. So for for this part, it would be going towards 0, towards y equals 0, which touches this point since it's the x-intercept. And for this part, it's also going towards 0, towards y equals 0, like this. So it's either like this, or like this, or like this, anything. We'll see later. But it should be here. For for y that is approaching negative infinity, which is these two parts, it's now changing to this shape instead, because it's approaching y equals 0, but in the negative area. So since we know that this is the stationary point, we can draw the graph like this for the middle part. And for y approaching positive 0, which is not in this graph, for y approaching positive 0, it's not in this graph, because in this graph there's nothing that is approaching y positive 0, and there's also nothing approaching negative 0. But I can say that if the graph is, let's say the graph is like this, let's say this is the graph instead, this part will be transformed, this part will be transformed to this shape, or this part will be transformed to this shape. So it's like a curve like this. This is what it means by this part. So for now, for this part, we need to move it move it to above the asymptote. So we get a shape that is roughly like this. Sorry, it's a bit ugly. Roughly like this. Because this is the stationary point, and this is approaching y equals to 1. And for this part, we can draw it like this. Because we basically flip this down. We need to put it down. So this should be the sketch of the curve. Oh, and last part. Fx and 1 over fx meet at y equals to 1 and y equals to negative 1. So we know that when y equals to 1 in fx, it should be y equals to 1 here also. Sorry, y equals to negative 1 here also for 1 over fx. Because that point remains the same. For part E, we need to find the set of values for which 1 over fx is lesser than fx. So we need to compare these two graphs, and we can say that for this part, fx is definitely larger than 1 over fx, because this is above y equals to 1, and this is below y equals to 1. So this will be the first part, that 1 over fx is smaller than fx. For the second part, it should be this area. Because we can see that 1 over fx is 1 over fx is smaller than negative 1 for this part, and fx is larger than negative 1 for this part. And the third part would be this region, and this is obvious enough. So now we need to find the x coordinates for which for this part, for this one. So basically we equate the equation to negative 1. So x squared plus 2 over x squared minus x minus 2 equals to negative 1. X squared plus 2 equals to negative x squared plus x plus 2. 2x squared minus x equals 0. So x will be equal to 0, and x will be 1 over 2, and y is negative 1. So we know that the coordinates of this is this 1 over 2 and negative 1. This is also 1 over 2 and negative 1. How do I know that the x coordinates are the same? Remember this part where I say that fx and 1 over fx meet at y equals to 1 and y equals to negative 1. If they meet, that means they have the same x and y coordinates at y equals to 1 and y equals to negative 1. So we also need to find for the x coordinate of this. So we equate the equation to 1, and we get x squared plus 2 equals to x squared minus x minus 2, and x is equals to minus 4. So this would be minus 4, 1, and this is also minus 4, 1. So now we can say that for the region that 1 over fx is lesser than fx, it's minus 4 less than x less than negative 1. This is the first region, which is this area. And for this region, it's 0, x, and 1 over 2. And for the third region, which is here, it's basically x larger than 2.